Now we will be exploring the topic of phenotypic plasticity. In our imaginary scenario here, this is the purple side of a universe where the entire environment is purple and all the cats that live here have the phenotype for purple fur. On the yellow side of this imaginary universe, all the cats that live here have the phenotype of yellow fur. But when the cats of the yellow side of the universe decide to up and move to the purple side, maybe because the weather is better or perhaps the food there is better. But once the yellow cats make it to the purple side of the world, their fur changes to purple over time instead of the yellow they originally had while living on the yellow side of the world. The yellow cats changing their fur phenotypes depending on their environment is an example of phenotypic plasticity. But how do we tell phenotypic plasticity from natural selection? Say you do an experiment to explain this difference. You gather several species of dogs of different colored fur phenotypes in a neutral environment. Like this red environment we put our imaginary dogs in this made-up scenario. Over time, some of the dogs may change their phenotype according to the environment. The dogs whose fur phenotype changed to red over time are the dogs with the genotype of phenotypic plasticity. Their genome encodes for their fur phenotype to be able to change according to their environment. The other dogs did not change color because their genome does not include the gene for phenotypic plasticity and their fur will not change according to the environment. The difference between phenotypic plasticity and natural selection is that phenotypic plasticity happens over an organism's lifetime, while natural selection happens over multiple generations, not over an organism's lifetime. Now that we understand phenotypic plasticity and how it differs from natural selection, let's move on to our next point of learning.
Created using Powtoon.